Hello and welcome to Vodcast 6.2. In this Vodcast, we will overview seismic waves. Before talking about the two types of seismic waves, let's get a working definition for seismic waves. Seismic waves are the form of energy released by earthquakes that travel through the lithosphere and Earth's interior. To understand how seismic waves travel, imagine dropping a rock in a very still pond. The impact of the rock with the surface of the water will create concentric circles of waves, and those waves will spread in all directions. Well, just like dropping a rock into a still pond, earthquakes generate waves that radiate out in circular patterns in all directions. There are two main types of seismic waves generated by earthquakes. The first type of seismic waves that we'll consider are surface waves. And surface waves travel in the rock layers just below Earth's surface. It's important to note that surface waves are responsible for most shaking and most damage to human structures during earthquakes. If you take a look at the image shown on the screen, you'll see that there are two types of surface waves. The first type of surface waves travel along Earth's surface just like ocean waves. And with these waves, you see the ground moving up and down. The second type of surface wave moves the ground from side to side, and these waves can be especially damaging to building structures. One other important note to make about surface waves is that they'll be the last type of wave to arrive during an earthquake. If you take a look at the seismographs shown here for number 1 and number 2, the surface waves will always occur after the P waves and the S waves. Speaking of P waves and S waves, the second type of seismic waves are known as body waves. And body waves will travel through Earth's interior. There are two types of body waves. The first is called a primary wave, also known as a P wave, and the second is known as a secondary wave, or an S wave. And on our next slide, we're going to turn our attention to these P waves and S waves. Let's start off by talking about the primary waves, or the P waves. P waves are the fastest of all earthquake waves. And in understanding their mechanism of travel, they push and pull rocks in the same direction that the wave is traveling. As an example, take a look at the slinky shown in image A. If you compress the slinky and then release it, that wave of energy will travel down the slinky. When P waves travel through Earth's interior, they move in the exact same fashion. And when they do so, they will actually temporarily change the volume of the material. And it's also important to know that P waves can travel through solids, liquids, and gases. In other words, P waves can travel through just about anything inside of Earth. Now, secondary waves are a little bit different. In secondary waves, the particles will be shaken at right angles to the direction that the wave was traveling. And as a good example of how secondary waves behave, we can look at image B. If you imagine shaking a rope up and down violently, you'll see crests and troughs produced as the wave travels from left to right. Now, the particle motion is occurring in the up and down direction, but the wave is moving from left to right, meaning that the particles are being shaken at right angles to the direction of motion for the wave. Now, keep in mind, our slinky example was different. For our slinky, which helped us conceptually understand how P waves move, the particle motion and the wave direction are in the same direction. That slinky compression traveled straight down the slinky. But for our rope analogy, which helps us visualize the movement of secondary waves, the material will oscillate at right angles to the direction of the wave's motion. An important note to make about secondary waves is that they can only travel through solids. They cannot travel through liquids and gases. And that's going to be especially important in our next video podcast. Now that we know what P waves and S waves are, we can talk about locating the epicenter for earthquakes. There are two very important facts to consider on this slide. The first one is that P waves travel faster than S waves. When we record an earthquake, the P waves will arrive first, they're the primary waves, the secondary waves will arrive second, and then the surface waves will be the last to arrive. The other important fact to note is that the difference in arrival time is going to be exaggerated by distance. Let's take a moment to study this travel time graph. The P wave curve is shown in blue, and then the S wave curve is shown in purple. On the vertical axis is the time in minutes since the earthquake, and the horizontal axis represents the distance from the epicenter. Your bottom horizontal units are kilometers, and your top horizontal units are going to be miles. As I've already stated, the P waves are faster than the S waves. As an example, if you're 6,000 miles away from an epicenter for an earthquake, the P waves will arrive in just about 9 or more minutes, but the S waves will take almost 17 minutes to arrive. So if the P waves arrive in about 9 minutes and the S waves arrive in about 17 minutes, there will be an 8-minute gap between the arrival of the P waves and the arrival of the S waves. That's an extremely important concept, because if we know the difference in arrival time between the P waves and the S waves, we can approximate the distance from the epicenter for the earthquake. Let's consider an example. Let's suppose an earthquake hits, and we have seismogram recordings from 3 different stations, one of which is located in New York, the other of which is located in Alaska, and the other of which is in Mexico City. Let's look at seismogram A first, which is the one from New York. Every one of those vertical bars represents 1 minute of time. So if the first P wave arrived here, let's count over the number of vertical bars until the first S wave arrived. I count 1, 2, 3, 4, 5 minutes in between the arrival of the first P wave and the first S wave. Knowing the difference in time between the first P wave and the first S wave is 5 minutes, let's go back and look at our travel time graph. Already marked on this graph is that 5-minute difference shown here. And if you're wondering how we get that 5 minutes, the P wave curve seems to be close to about 6 3/4 minutes maybe, and the S wave curve seems to be very close to 11 3/4 minutes, while the difference between 11 3/4 and 6 3/4 is 5 minutes, based on my rough estimation for the times. So what does that tell us? Well, take a look at the horizontal scale, which is the distance from the epicenter. If we want to measure that in kilometers, we would extrapolate straight down to the horizontal axis, and that appears to put us in between 36 and 3,800 kilometers, so let's call it 3,700 kilometers. That 3,700 kilometers represents the distance from New York to the epicenter of this earthquake. So what we would do with a compass is we would center the needle on New York and draw a circle with a radius of 3,700 kilometers. Now the epicenter could occur anywhere on this circle. We don't know where on the circle it occurs, we just know that it's somewhere 3,700 kilometers from New York. To locate the actual epicenter, we need data from 2 other locations, because if we draw circles centered on those other 2 locations, the epicenter will be located where all 3 circles intersect. For the sake of time, I'm going to skip seismogram B and go to seismogram C, just to help you understand how we interpret data from this travel time graph. If we look at the data taken for Mexico City, let's see how much time elapsed between the first P wave and the first S wave. Based on my counting abilities, it looks like 1, 2, 3, 4. So 4 minutes elapsed between the first P wave and the first S wave. Let's go back to that travel time graph and try to figure out where there's a difference of 4 minutes between the P waves and the S waves. If you look at the vertical line that represents 3,000 kilometers, it appears to me that the corresponding S wave time would be about 10 minutes, and the corresponding P wave time would be about 6 minutes, maybe a little less. So at 3,000 kilometers, I would say it's slightly more than 4 minutes difference. Now if you go over and look at the image at the far right, the circle was drawn with a radius of 2,900 kilometers, which is slightly less than the 3,000 kilometers that I was kind of looking at in the graph. And if you want to pause the video at this point and try to determine Nome, Alaska's distance from the epicenter, I strongly suggest you do so, because you may see quiz and test questions just like this. Okay, as I mentioned just a short while ago, you will have to do some problem solving with the travel time graph shown on the left of this slide. At this point, I'd like you to pause the video and try your best to solve these 2 questions. Once you hit play, I will go over the answers in detail. Okay, hopefully you've tried to solve these 2 problems. Let's go over the answers for each of them. To answer this question, let's extrapolate over horizontally at the 7-minute mark. Conceptually speaking, we're talking about how far the S waves and the P waves have traveled 7 minutes after the earthquake occurred. Now the P waves look like they've traveled 4,000 kilometers. But to answer this question, let's take a look at where my extrapolated line crosses the S wave curve. That appears to be at about 2,000 kilometers. So the question asked us how much distance had been covered by an S wave, and the answer would be 2,000 kilometers. For the second question, we're told that the arrival time difference between the first P wave and the first S wave is 3 minutes. And the question asks how far in miles we were from the epicenter of the earthquake. To solve this problem, we have to take a look at the 2 curves and try to figure out where 3 minutes separate them. The line I'm going to focus in on is the vertical line that stretches up from the 2,000 kilometer mark. Because a P wave will take 4 minutes to reach that 2,000 kilometer mark, and an S wave will take 7 minutes to reach the 2,000 kilometer mark, and the difference between 7 and 4 is 3. Your answer should be something like 1,200 miles or a little bit more than that.